Hey guys, today we are going to begin a lesson on the rhombus, the rectangle, and the square. We'll focus in today specifically on rhombus, a quadrilateral with four congruent sides. Okay, so a quadrilateral with four congruent sides is a rhombus. A corollary to that, which just means something that logically follows that, is that a quadrilateral is a rhombus if and only if it has four congruent sides. So here is a quadrilateral, ABCD, and it is a rhombus if and only if AB is congruent to BC and CD and AD. Some theorems about rhombus diagonals. A parallelogram is a rhombus if and only if its diagonals are perpendicular. So in a rhombus, diagonals must be perpendicular. So parallelogram ABCD is a rhombus if and only if AC, segment AC, is perpendicular to segment BD. Okay, so if those two diagonals are perpendicular, then ABCD is a rhombus. A parallelogram is a rhombus if and only if each diagonal bisects a pair of opposite angles. So parallelogram ABCD here is a rhombus if and only if segment AC bisects angle A and angle C. Okay, so both of these two angles, A and C, are bisected, which they are. I know that because these two are congruent, and then these two are congruent. And if segment BD bisects angle B and angle D. Okay, so this diagonal has to bisect its two opposite angles, and it does. Two tick marks here, two here, two here, and two here. Okay, so we are going to sketch a rhombus FGHJ and list everything we know about it. So here is a rhombus FGHJ. Okay, so some things that we know about it. By definition of a rhombus, we know that FGHJ first is a parallelogram. Okay, so this is a parallelogram because opposite sides are congruent. We also know that it has four congruent sides. Okay, so one tick mark on each of the four sides. So it's a parallelogram that has four congruent sides. Because it's a type of parallelogram, we know that opposite sides are both parallel and congruent. Okay, opposite sides congruent is already marked because all four are congruent. We can also mark opposite sides are parallel because it is a type of parallelogram. We also know that opposite angles are congruent. Okay, and we'll mark that later after we put in some diagonals. We know that consecutive angles are supplementary. Okay, so these two have to add up to 180 degrees. These two have to add up to 180 degrees. And all the way around, any two consecutive angles will have to add up to 180 degrees. We also know that the diagonals bisect each other. Okay, so I'll draw in a couple diagonals here. And I know that those two diagonals bisect each other, so I can put 2 tick marks here and here, 3 here and here. By the rhombus diagonal theorems, we know that the diagonals are perpendicular and that they bisect opposite angles. So I know that there are right angles in here. And I know that these are congruent. And so are these. And then these are congruent. And so are these. Okay, so those are all the properties that we know about a rhombus at this point. So using those properties, let's find the values of x and y here. Okay, so in a rhombus, every side is congruent to every other side, so I know that 6y minus 5 is equal to 3y plus 7. So I can subtract 3y from both sides, and I can add 5 to both sides, and I get 3y is equal to 12. And I can divide both sides by 3 and get y is 4. I also know that consecutive angles are supplementary. So that means 2x minus 1 plus 127, so these two angles added up together would make 180 degrees. So I can add this 1 and subtract this 127 and get 2x equals 180 plus 1 minus 127 is 54. And I can divide both sides by 2, and 54 divided by 2 is 27. And last, with a rhombus, we want to find every angle measure and every segment length in this picture. Okay, so I've got a 6 here, which means there's a 6 here because diagonals bisect each other. I also know that angles are bisected by the diagonals, so if there's 30 here, then there's 30 degrees here. And opposite angles are congruent, so if there's 30 degrees here, then there's 30 degrees here. I know that diagonals are perpendicular, so I know there's right angles in the center. I know that in this triangle, if I have 30 and 90, that's 120. A triangle is 180, so there's 60 left. So there's 60 here and here because these diagonals are bisected. These diagonals bisect the angles. And opposite angles are congruent, so there's a 60 here and a 60 here. So I now have every angle measure. What I'm missing is some segment lengths. I'm missing these 2 segment lengths and all 4 side lengths. So I'm looking at 4 30, 60, 90 triangles. And in a 30, 60, 90, the smallest side is to 1, as the longer leg is to the square root of 3. So I've got 1, 2, square root of 3. So 1 and square root of 3. So I've got TS is to 1, as 6 is to the square root of 3. TS over 1 is just TS. So I can just multiply top and bottom here by the square root of 3, and I get TS equals 6 root 3 over 3. And 3 goes into 6 2 times, 2 root 3. So this right here is 2 root 3, and this is 2 root 3. Okay, so remember a 30, 60, 90 is 1, 2, square root of 3. So 2 and square root of 3 matter to me now. PS is to 2, as 6 is to the square root of 3. And I can multiply this 2 across, and I get PS equals 12 over the square root of 3. And then I can multiply top and bottom by the square root of 3, and I get 12 root 3 over 3. And 3 goes into 12 4 times. 4 root 3. So every side length of this rhombus is 4 times the square root of 3.